In this video, we're going to review our definitions of our trig functions, sine, cosine, and tangent, and their reciprocals. And so let's go ahead and start with this idea of having an angle in standard position in the xy coordinate plane. So if I have an angle in standard position, it starts on the positive x-axis here, and let's say it terminates in the second quadrant here. And so this is our angle theta. Recall that as long as we know a point on the terminal side of our angle here, xy, where this intersects a circle of radius r, then we can kind of create a right triangle out of the situation here. And so I'll go ahead and highlight this in blue. But here's our triangle. And of its parts here, we know the x and the y, given the fact that we know this point on the terminal side. And so that being said, our distance r here is just this distance from the point to the middle. We can define our three trig ratios, traditional trig ratios thusly. So sine, cosine, and theta, just using SOHCAHTOA, our sine of our angle here would be opposite over hypotenuse, or y over r. Our cosine would be adjacent over hypotenuse, so x over r, and our tangent would be y over x, or opposite over adjacent here. And these are all with respect to the inner reference angle here, but the bottom line is this is how we define our six trig ratios. And while we're at it, we could say that don't forget that cosecant is the reciprocal of sine, and so this would be r over y. If we were talking about secant, which is the reciprocal of cosine, this would be r over x. And if we're talking about cotangent, which is the reciprocal of tangent, we would have x over y. And just a real quick reminder that r is always positive. So I want to know that you guys are very comfortable with this definition of our trig ratios. So let's kind of try to use these to help us find these six trig ratios up here. It says, given an angle theta in standard position whose terminal side passes through the point -6, -8, find the values of all six trig functions here. And so it looks like we already have a point on the terminal side. I do want to sketch this angle is kind of where I want to start, but I noticed that this would go left and down. I'm going a little bit further down than I would go left. So kind of if what I want to do here is label this -6, -8, we know that this is an angle in standard position, so starts on the positive x-axis, and that our terminal side runs through that point right there. So here's our angle theta. The bottom line though is that when we drop our altitude back, here's our triangle, and we know that the x value is -6 and we know the y value is -8. So the only thing we have kind of remaining to find here is our r value, and we can kind of always use Pythagoras to help us go do this. So in this case we get 36 plus 64, which by the way is totally 100. So if 100 equals r squared, we get the square root of 100, which is plus or minus 10 to be our r, but we always keep our r value is positive. So knowing these three values now, we can go just put our ratios together. Our sine ratio should be y over r. Well, our y value here is -8, and our r value here is 10. We're going to get -8/10, or in other words, -4/5 once we reduce it. Hey, moving on to cosine. Cosine is x over r. Our x value is -6, and our r value is 10. So in this case, we get -6/10, which is -3/5. And then for our tangent value, we get y over x. Our y value here is -8. Our x value is -6. We get -8 over -6, which is positive, and is positive 4/3. And at the same time, we can find all of our reciprocal ratios just by flipping these over. So -5/4 is our r over y, -5/3 is our r over x, and our x over y would be 3/4 here. So just being very comfortable and familiar with these definitions of our trig ratios, we're going to use them all the time. Cheers.